In the course for secrets management for critical infrastructure, we'll look at the interconnection of devices and how they are able to work together as a single system, and how that interrelation is done and managed is a big part. So each device requires a root operation and management capability to allow the network to operate as a single system. That way, anywhere they're plugged in, you know how they're going to operate. Making a base part of each node the same for every node provides kind of that Lego block type of approach, where no matter what the size and the use of the system, they all plug together by the interlocking capability of each block being the same, each piece being the same, and each device having those same capabilities that link to upstream and downstream devices. This base operation of the nodes has two portions, really. The minimum root secrets, or DNA, required to connect all the nodes together and make sure that they can operate the same, so they can be synchronized by the active trust management on the network and across the network. And then operational restriction for access to those root secrets, so they can only be accessed in accordance with the management and agent needs, so that they can't be used or exploited outside of their required access. This secrets management framework combines the security basis for both the IT and industrial control systems, supporting both synchronous and asynchronous operations. For the synchronous needs and operations of synchronous networks, each node can produce temporary or session keys. The nodes can then use this single session key for sessions up to the enterprise trusted key management, or to encrypt personally identifying information or data reads from that particular node and send them up to the enterprise systems and the enterprise networks through the security management gateway. This synchronous operation also allows for any node to be authenticated uniquely on the network. So this provides for that operation for disconnected networks while maintaining the security posture. If this network would ever not be connected to the enterprise network, each node can then create a message authentication code, which can be verified by any other node on the network to allow it to continuous operation for that availability needs for the critical infrastructure networks. Each node then can also produce the same key anywhere in the network for shared temporary use keys. These keys can be used to encrypt communications on the fly or to verify communications and communication integrity in real time. Also for rotating and synchronizing across the network to refresh and renew the security posture. With key rolling techniques, you can synchronize rapidly to support embedded system needs for controlled system networks. This allows those closely timed critical infrastructure networks to change keys and rotate and change security posture more often as required for operation. And the key management structure also supports asynchronous operations where time sensitivity is not as much of an issue. Certificates and asymmetric communications be provisioned when users add them to the network as a way of network node asynchronous authentication. Nodes can exchange public keys as needed and create sessions dynamically as needed for network communications. Reprovisioning, when compromise occurs, or for certificate update management, then can be done using a certificate authority or certificate servers. This allows for cross-certification and enables trust between multiple networks and multiple organizations, even companies and different organizations outside, so where utility companies have to interconnect and talk to each other for different rate usage or for roving loads such as electric vehicles.